So the quotient rule for derivatives helps us to find the derivative when we have a quotient of two functions. It's pretty similar to the product rule in that sense. And let me also mention that this does not equal simply the derivative on top divided by the derivative on the bottom. These two are not the same. So we're going to have to find a better way to figure out the derivative of a quotient. There are two ways to do this. You can do it the same way we did for the product rule. That is, set y equal to the quotient, do the natural log on both sides. You'll have when you have the natural log of the quotient, you'll have a difference of two quotients. But I'm going to leave that to my viewers to do on their own. The other way we can do this, that's the way I'm going to do it, is by using the product rule. Because a quotient is really also a product. So let's take a look at that. When we have f over g, that's the same thing as saying f times 1 over g. And when you have 1 over g, that's like saying fg times g to the negative first power. Yes, this is f times g to the negative first power, not contra bassoon, bassoon minus 1 octave. Just thought I'd mention that. And now we have a product of two functions. So we can use the product rule. And perhaps I will color code this a little bit. So let me write this down in some colors to make it easier to follow. So I'll write this down in purple, and I'll write this down in green. So, using the product rule, first thing is we keep the first function, so that's f, and then we multiply by the derivative of the second function. I'm not gonna work that out yet. I'm just gonna leave it as d dx of g to the negative first power. I apologize if all my shades of colors aren't exactly the same. You get the idea. Then for the second term in the product rule, we keep the second function, so that's going to be g to the negative 1 power, and then we multiply it by the derivative of the first function. So we'll put down d dx of f. Alright, now let's see if we can clean this up a little bit. So firstly here we still have this f in the front. Now we have to take the derivative of g to the negative first power. So let me open a parentheses for the result of that. So the first thing we have to do is use the power rule. So I'm going to take this negative 1 and bring it to the front, because that's how I use the power rule. So we're multiplying by negative 1. And then the input stays the same, so that's our g. And then, but now we have to subtract 1 from the power. So this is now being raised to the negative 2 power. But don't forget the chain rule. Multiply by the derivative of the inside function. So the derivative there will be dg dx. Alright, now let's deal with the second term. So this one's easier. We still have the g to the negative 1 right here. And then the derivative of f with respect to x, that's this right here, is just df dx. Alright, so now we're done with the derivative. So now we just have to organize this and turn this into the quotient rule the way we usually view it. So firstly here we have a negative. So let me put that down in front. And then here we have a g to the negative 2. So we know that we can write this as a fraction with denominator g squared, because g to the negative 2 is like 1 over g squared. And perhaps I'll keep this in my colors. So I'll have the negative sign here, and then the g squared will be in the denominator. And then we have the f, and don't forget about this right here, the dg dx. And then we we have to add this with. So when you have this g to the negative first power right here, that means we're going to have a fraction with denominator g to the first power, or just g, and then the numerator will be this right here, df dx. So now I'm just going to clean this up a little bit. I'm going to combine these two fractions. So I'm going to multiply this fraction right here, top and bottom, by g, so I can get the common denominator. And let's see what that gives us. So, if we're going to have a big fraction here, and our new denominator for the whole fraction is going to be g squared. And then for the first term, we still have our negative f times dg dx, and then plus, we have this g right here that we have to multiply by the df dx. So we'll put down g times df dx. And now to turn this into the quotient rule as it's usually written, all I'm going to do is switch the order of the terms in the numerator. So for our denominator, we'll still have our g squared. And in the numerator, I'm just going to switch the order, so I'm going to put this term first, so we'll have g times df dx. And then minus, don't forget this minus right here, f times dg dx. And this is the quotient rule as it's usually written. And there's a mnemonic to remember this, which your teacher will probably explain to you. He did with me, so that's why I went with. The mnemonic is low, d high, minus high, d low, over low squared. That's right. Low d high minus high d low over low squared. What does that mean? Low, it's the bottom function, g. This is the original bottom function, of course. Don't forget, this is all the results of the derivative of f over g. I know it's been a while since we saw that. So we have low, that's our g, d high, derivative of the high function, the top function, which is f, the derivative of f is df dx, minus is minus, high, the top function, f, times d low, the derivative of the bottom function, df, dg dx, over low squared, the bottom function squared.